Assalamualaikum, a very good day to all of you. Hi, I'm Shikin Aziz. Alright, today I will cover a topic on vessel supports. Alright, this topic is one of the topic under syllabus of process equipment design. The code is EPFO 801. So this lecture material contains I prepared for my bachelor degree student for the Bachelor of Process and Food Engineering. Alright, so uh, for the vessel supports, alright, as we've been, this is one of the among the element, okay. The how to say the design structure, okay, that attached to the vessels or tank. Yeah? So uh, previous topic we have covered on silo. Basically, that is a storage for particulate storage. Or another word is for bulk solid. Sorry, for bulk solid storage. All right. So we have that. I have covered on how to design the hopper. All right. The hopper is basically around this area. Hold on. Okay, hopper is basically around this area. Okay, but when we design storage equipment for the bulk solids, right? But we also will have to design the cylindrical part. All right. So this is a common things. Okay, common shape. All right, of the tank, of the vessel that we can see outside there in the industry. So this also the shape of the tank that will be used to store liquid, okay, product or other liquid. I mean anything your our processing liquids. All right. So uh, so the what we have the things that covered under the tank design, under the vessel design, such as the last time for the previous class, so for sorry for previous recorded lecture. Okay, for previous recorded lecture, we have covered on how to find a minimum thickness for the cylindrical shell or sphere shell. All right. So those calculation method is also is applicable for other type of storage. Okay, as long as the shape is the same. Okay, because the function is the same. All right. Okay. So now for this lecture, we will cover on vessel supports. So vessel design component will involve depend on the how it works. Okay. So if you need a hopper, you need to design the hopper. All right. And then other than that, you need to as well to design the support. Okay, there are several support of it. All right. So another thing that you need to know how to calculate the thickness of this part. All right, the cylindrical shell. Okay, and then there is also calculation that we need to calculate the base of the vessel. All right. So for this topic, we will have a look on this. Okay. Uh, Vessel supports. All right. So factors. This is a list of factors for vessel support. Okay, for vessel support designs. Right. So uh, actually, the method used to support a vessel. All right. Okay. I mean the design. Okay, that been used to support a vessel. Uh, it will depend on the size, shape, and weight of the vessel. uh, and then and it also will depend on the vessel arrangement. All right, the vessel arrangement, the design temperature, design pressure, and vessel location. All right. So sometimes, when we talking about the vessel location, because sometimes the weather factor, okay, is also affect our design criteria. All right. So vessel, there are two type of vessel. The configuration of the vessel, there are two type. Either you put it vertically or vertically. You put it vertically or horizontally. All right. So for horizontal vessel, common support is two saddle support and bracket or brackets or lugs. All right. While for vertical vessel, common support we will use as a skirt support. Skirt support are more stronger compared to the bracket or lug. So brackets or lug is commonly been used for the short vertical vessel. And then you must know that support must able to carry weight of the vessel and content, and it must also uh, can able to carry any superimposed loads that can caused by the wind loads. Okay, for example, the wind loads. And then uh, you must know also that the support also can impose a localized loads on the vessel wall, and the design must be checked to ensure that the resulting stress concentration are below, the maximum allowable design stress. All right. So, and then another things, you must also know that normally we do have a manways, okay, on the at the bottom of the vessel. So you must consider also, must take into consideration that the support type or the support design will allow easy access, at the bottom of the vessel, okay, where normally be an access for inspection and maintenance. Okay, saddle supports. All right. There are several type of support. Saddle support, bracket support, skirt support. All right. That is three common design. Okay. Now we look at a saddle support. So saddle support is most commonly used support for horizontal cylindrical vessels. Um, and then sometimes in other design they will use legs, okay, but this is for small horizontal vessel. The two cross sections is normally installed, two saddles, which is two saddle normally installed. All right. Why not more than two is because uh, is because uh, how to say it. All right. If let's say you use more than two saddle, then you need to calculate, okay, the distribution of the loading. All right, between the saddle, and then you're going to be quite complicated. All right. Okay, and because sometimes the loading is uncertain. All right. And then a vessel supported on two saddle uh, can be considered as supported beam. All right. Right. Okay. And then maxima, okay, maxima, how to say this? Oh, sorry. Uh, okay, a vessel supported by the two saddle like this. All right. Where is my? Okay. Oops, sorry. No, it doesn't want. All right. Two saddle like this for vessel that support by two saddles like this can be a vessel supported by two saddle of this is normally there, it will have uniform load, and the distribution of the load we can see here. All right. The distribution of longitudinal, okay, this is considered a longitudinal axial bending moment, okay, will be uh, as shown in this figure. All right, this is the what they call it just now. Longitudinal bending moment. Longitudinal bending moment. Okay, this all right, this shows the distribution of longitudinal bending moment. All right, and then the maxima of this, all right, the maxima of this bending moment occurs at the supports. Okay, occurs at the supports, and it occurs at the support. This is the support, all right, and at the mid span. Okay, at the mid span. So basically, the way that the common ways of deciding a location of support, okay, we need to find where the shear area with minimum stresses impact. All right, so then we don't need additional reinforcement. All right, so the theoretical optimum position, normally we need to find the maxima at support where is equal to maxima at mid span. Okay, all right, the maxima at the support and at mid span are equal in magnitude. All right, and then common material construction being used are bricks, concrete, steels, and then the contact angle for the support is normally not less than 120 degree and not bigger than 150 degree. All right, so talking about the stresses on the saddle support, all right, they are actually comprehensive. Okay, how to say this, yeah, comprehensive. There is a detail equation to calculate the longitudinal bending stress. There are the tangential shear stresses. Okay, but this will not be covered under this subject. All right, but if let's say you would like to know further, okay, let's say in the future you would like to you would like to investigate more for your plant design project, you can find a lot of reference. Okay, there are several references being suggested by the textbook. You may refer your textbook. All right, and then so this is an example, okay, a part taken from the textbook, okay, from the textbook. Okay, I showed here, and then I show this figure here for explanation. All right. So this is typical standard saddle design. All right. So if you can refer here, there is this is basically for A. This is table A for vessel up to 1.2 millimeter. Okay. So this one is, where is my, oh, sorry. All right. This is, couldn't find my, all right. This is for vessels up to 1.2 millimeter. Okay. They provide the maximum weight and then the dimension for Y. This V, you can refer where is V, E. Okay, the dimension of E. So you can refer this as a to guide. This table can be used to guide your design, and then it's very detailed, the calculation, the dimension given here, and then there is a value for the saddle dimension as well. And then this is we call it the degree for the contact angle. All right. between the saddle supports and the center of the vessel. Okay. So normally, to take up any thermal expansion of the vessel, for example, let's say your vessel is act as heat exchanger, the anchor box holes in one saddle can be slotted, so it allows for expansion. All right, and then uh, the next table shows. This next table show the standard uh, what they call it, typical standard for the saddle design uh, for what just now, for vessel greater than 1.2 meter, for vessel greater than 1.2 meter, 1.2 meter. So this one is for vessel greater than 1.2 meter. All right. Then let's look skirt support. So this skirt support are commonly used for tall vertical vessels such as distillation column. And then the shape of a skirt support, it could be cylindrical or conical shell structure. And then it's normally well on the base of the vessel. So this is cylindrical, all right, the cylindrical shape, all right. And then this is conical. You can see there is conical shape there. Okay. The flange, okay, the flange at the bottom of the skirts, all right, the flange at the bottom of the skirt will transmit the load to the foundation, okay, this foundation, all right. So, and then for this skirt support, you need to put, I think I put somewhere here, uh, I did type somewhere here, but okay, but it's okay, I explain here. For skirt support, you need to include opening. Okay, so these openings, all right, will be used to will be used for accessing the bottom part of the vessel, and also for connecting the pipes. So, and then this opening normally you need to reinforce, okay, the opening. And then what are the things? All right, and then and then this is type of assembly. Okay, there are three type of assembly. So for this A, all right, this we call it welded flush with the shell. Welded flush with the shell. And the other one is welded to the outside. Okay, to the outside of the vessel shell. And then this is wrong. This is not welded. This is actually welded arranged. This is welded flush with the shell. Alright, sorry, welded flush with the shell. And this one, this is where the welded to the outside of the vessel shell. Okay, this is outside. This is flush. This is at bottom head. Okay, bottom head. All right, bottom head of the vessel. All right. Okay. Then for calculation for the skirt thickness, okay, the calculation is actually to ensure that the skirt thickness must be sufficient to withstand the dead weight, loads, and bending moment imposed on the skirt by the vessels. All right. So the resultant stresses in the skirt will be uh, this. We have tensile and for compressive, where uh, okay, where sigma bs is bending stress in the skirt, bending stress in the skirt, and sigma ws is for the weight stress in the skirt. All right. uh, And the other parameters that needed is maximum bonding moment, total weight of the vessel content inside base diameter of the skirt, and the skirt thickness. And then the design criteria for the skirt thickness, okay, where the skirt thickness should be such that under the worst combination of wind and dead weight loading. This is the criteria, okay, in order to ensure that we can follow the design criteria. All right. So where we do tensile stress and compressive stress. All right, and it shouldn't be bigger than the left part. Okay, it shouldn't be bigger than the right part. All right, the right part. And then the minimum thickness, you must remember that should not less than 6 millimeter. All right, if let's say you calculate, you get less than 6 millimeter, that's mean there is something that you need to consider, reconsider the parameter that been used. All right, and then if let's say the vessel wall will be at significantly higher temperature than the skirt, if let's say your vessel wall been used to store a high temperature liquid or any material, then you need to ensure to ensure that discontinuity stresses will be set up due to differences in thermal expansion. All right. So for this, there is other textbook, there are the reference that you need to refer to consider the thermal stresses in skirt supports, where basically the one that I explained here is for very simple. This is for simple calculation, all right? It's for preliminary calculation, all right? And then, beside the skirt, all right, the main skirt shell, okay, the loads carried by the skirt also are transmitted to the foundation slab, okay, by the skirt base ring, or other name for it is base plate, a bearing plate, sorry. Okay, before we go further, let me show you what is base ring, what is anchor bolt design. Let's look this photo. Okay, this photo I borrowed from this website. All right, and this photo looks here. Okay, this photo show you the location of base ring. Okay, this location show you the location of base ring. All right, and this is the place of for bolt holes where it at the stiffening rings. Okay, so all right. This photo shows a cylindrical skirt. Okay, so you can see there is opening here, and then there is another opening for piping, for pipe network. Okay, for piping work. All right, and there is also opening here for vent hole. All right, there is opening for vent hole. This one example of the design. Okay, it's depend on the requirement of your design actually. All right, and then what is the anchor bolt? Anchor bolt. So this is anchor bolt. This is anchor bolt. All right, and this is the place for the bolt holes. Okay, this is the real photo. All right, so uh normally the design for the people will choose skirt support when the vessel is outside of the a building, outside the building, or in other words, the vessel is at in open area. All right. So So thus there is a moment, okay, moment produced by wind and other lateral loads. So these loads will tend to overturn the vessel. Okay, so uh, so due to this load, we need to prepare our skirt support. So the design for the skirt supports can withstand the loads is by having the weight of the vessel, okay, the weight of the vessel, and plus the tensile load, okay, the tensile load in the anchor bolts, in the anchor bolts. All right. And then there are actually several types of base rings design, okay, which are used for skirt support. And then the simplest types, suitable for small vessel, the roll angle. Okay, this is the roll angle, right? The roll angle, this type roll angle. Okay, and then the other one, the roll angle and plane flange. Okay, roll angle and plane flange, plane flange rings. Okay, plane flange rings. Okay. So and the roll angle and flange. Okay. This both of these. Okay, and a type of play roll angle, with and plane flange rings. All right. While for C, okay, the C for C design, they call here the name for it is double plate with gusset. Okay, so and it's also known as chair supports because the shape like a chair. All right, chair supports. So for C design is commonly used for larger columns. All right, for a larger columns. So for detailed design of base rings and anchor bolt, can be obtained from other reference. Okay, the other references you can refer from your main textbook. All right. This is not being covered in this our main textbook our main textbook, chemical engineering design by Towler and Sinod. All right. So, uh, right. So now let's look on bracket. Okay, bracket support. Another type of support known as bracket supports. Okay, and the other name for it is Lugs. Okay, so this support is commonly used for short vertical vessels. Okay, an example of industry that prefer to use bracket or lug supports is food industry and pharmaceutical industry. All right, due to hygiene requirement. Okay, compared to skirt supports, all right, it will be very difficult for you to maintain hygiene area inside the skirt area because normally in food industry daily cleaning is mandatory in food industry and will use a lot of water. So due to this, all right, there are a lot of water accumulation, okay, inside the production area, especially on the floor, all right. And if let's say you are considering to use a skirt support, all right, so you need to bear in mind that you need to maintain the area inside the skirt area and in surrounding the skirt area. You must make sure that it's clean and dry, all right, because the presence of water or too humid area inside the production area is not good due to the risk of microbiological hazard. Alright, and we don't want this microbiological hazard going to transmit into our food product. Alright, so basically in food industry, if let's say the size of the vessels is not too big, all right, the best thing is to consider legs. Okay, leg support, okay, or bracket support or lugs. You need to consider lugs or bracket supports. All right. Or if let's say you need to have a tall vessels, all right, due to high capacity, then you can consider skirt support, but you need to take a precaution. There is a procedure to maintain the hygiene around the skirt area. For bracket for bracket and lug supports, okay, the lugs may supported on the building, okay, may be supported on the building, structural steel, or columns, or on legs, okay, or on legs, okay, such as the one that shows in this okay, drawing, okay. This drawing I've taken from our main reference, okay, main reference textbook, and this one is the example of the vessel with bracket support. So this one with the leg, all right. So you can use this is a guidance, okay, from the vessel handbook, all right, where best be the when to consider to use this type of support is when your vessel dimension is small to medium diameters, which is about 1 to 10, okay, sorry for this, 1 to 10 feet, all right, and moderate height to diameter ratio is 5 to 2, okay, all right. So the main load carried carried by the bracket will be the weight of the vessel contents, and in addition the bracket also must be designed to resist the load due to any bending moment due to wind or other loads, all right. And then if let's say the bending moment is quite significant, you need to consider skirt supports, all right, because skirt support is more stable compared to the bracket supports or lugs, all right. And then the reaction on the bracket is eccentric, okay. This is eccentric reaction, which means that the bracket will impose a bending moment on the vessel wall, okay, on the vessel wall here, around here, right, on the vessel wall. So the point of support at which the reaction acts should be made as close to the vessel wall as possible, so allowing for the thickness of any insulation. So right, then normally in order to carry the bending loads, all right, common practice is to use breaking plates, okay. This is example of breaking plates, all right, breaking plates, or other name for that is collars, all right. And there is another name for it, is we call it reinforcing rings, okay. This is I said breaking plate, not breaking plates, backing plate, all right, sorry for that. And then this drawing shows an example of bracket designs. There are two examples here. One is single, okay, with single gusset plate, and the other one is with two, okay, with two with two gusset, okay, double gusset plate, okay, double gusset plate. So there are expressions for calculating the maximum design load per bracket, all right. These two expressions, one for single gusset plate design and another one for double gusset plate design, okay. So and you need to have the characteristic dimension of bracket, the thickness of plate, in order to get the value for maximum design load per bracket. Alright, so that's it for now, class. Alright, that's it for now. which is covered under the material that's covered under our main reference textbook. Alright. To be honest with you, okay, this calculation from this textbook is not sufficient, all right. But because you are process engineer, you are only need to know some part of the design parameter that need to be informed to the mechanical engineer later on, all right. For this specialist of engineer that will go into detail in the designing of the vessel, sometimes it call it as a vessel engineer. Okay, so if you refer some of the reference in the inside your reference textbook, you can see that the calculations is very detailed. And for example, for what one type of supports, okay, like saddle support, it's covered under one chapter. So you can imagine how much, okay, the equation been involved inside the one chapter, okay, because it's only describe a saddle support in one chapter. Okay, so class, for extra reading, okay, I will include inside your learning system, okay, Putra Blast. Okay, see you again in next recorded lecture. Okay, bye. Assalamualaikum.